Okay.
Yes. Welcome here on the World Championship of the sporting class GPS, and we have here the designer, one of the designer for this plane, Pike paradigm, and we like to hear something about the way how it happened that this plane is now here with us.
Yeah, actually it's very nice that we finally have this plane. It was a kind of a longer journey until we had this plane, and prior to the World Championship round here, about 2 months ago, we had the first plane. So Samba model was doing a very good job just preparing a prototype, and right now about 15 planes already came out of the molds, brilliant aluminium molds, I need to say, and 8 of them are present here on the first World Championship of GPS Triangle Sports Class. And about 3 years ago, Benjamin Rodax and me, we took upon the endeavor to build, so to say, the next generation sports class plane. And with the technology and knowledge of Samba, who are nowadays, I think, really one of the best producers producing planes in full Roha cell core technology, we took this opportunity to push the limits in GPS Triangle Sports Class to this plane.
Yes, and you fly long time the Calvados. So what was the goal? What this plane should do better than the Calvados?
The goal always is, of course, to do everything better, but in an engineering world this is not possible. So we were thinking about what is the most important part of GPS triangle soaring, and actually when you hear the term GPS racing, everybody thinks about we are always racing, but most of the times actually it's thermal soaring. So GPS triangle is more like a thermal regatta than a race, and you need to be able to maximize your thermal climb, and therefore we said we would try to enhance the L/D performance so that it has a better glide ratio, but mainly the climb performance. And therefore you need to be able to fly on high lift coefficients because these planes are heavy. That's important. To be able to do a steep spiral climb, so to say.
Okay. Yes.
Yeah. And in the end, I need to say, we managed that the plane is not worse than other planes in speed, and it has almost or about the same performance in fast glide, but when it comes around thermaling, I think it has an edge over the other planes.
Yeah, perfect. So you have more span. How big is it now?
It's 4 meters and 72 actually. So we enlarged the span, and you need to be careful with this because you just can't enlarge the span to make a better plane. This would always enlarge in your L/D when you enlarge the span, but we are limited to 75 grams wing loading, so we are limited to an area of 93 square decimeters. That means when you enlarge the span, you will decrease the chord. And this will give you the difficulty of structural stress to take of the plane, so the torsion loads, the bending, and even to install the servos might be a problem if you go too big in span.
I think this to climb in a thermal is normally very easy with a light model, but you fly the most time with 7 kilo to have enough power and speed.
Actually 7 kilo is the limit.
Yeah.
I think if we would have the possibility to fly heavier, we would, because heavier is gliding better, you know that.
Check your model after.
There's someone with a scale, and 7 kilo is the limit, and 75 grams wing loading per square decimeter is the limit. Therefore it's 93.3 square decimeters. When you have an area of 93.3 square decimeters, you meet both criteria at the same time. And because of these heavy planes which are gliding very good, we want to have them circling at the same wing loading very nicely and show a good maneuverability and a nice behavior. when the planes would be lighter, of course they would climb better and they would fly better in the thermal, but then they are definitely weaker in glide.
Okay.
And this is what we don't want. So the goal definitely is to produce a plane which can thermal really nice at a high wing loading.
Okay, yeah. So the difference is also that you have now a longer fuselage, and a bigger fin.
Absolutely. It's because of when you enlarge your wing, you definitely need to take in mind the spiral stability of the plane. That means the steeper you bank the plane, the easier it will follow a spiral dive. And we don't want to have this. Everybody knows it when you circle with your plane, then you always need to hold a little bit opposite aileron in the turns. And the better your spiral stability is, the less opposite aileron you need to give in, which always produces some more drag. So you can circle a little dragless when you need less opposite aileron. And for doing this, you need a fairly large tail boom and a really big rudder. And this is why you see this on that plane. It also helps you on the straight line flight, of course. When you want to fly a straight line along the triangle, it tracks pretty well with a large rudder.
Okay, yeah, perfect. So this has also a 4. Was it also on a Kolb?
Yes, it has a 4 servo wing. We were thinking about a 6 servo wing in the beginning, but that means that you have a little more weight in the outer panels for an additional servo. And this means more inertia. And the next thing is it's so thin that you can only put an 8mm servo in there, and for a 7 kilogram heavy plane we didn't want to do this. So therefore we decided against the 6 servo wing. A 6 servo wing has other advantages, but I think somebody else will explain you that. So yeah, this was our approach, to have a 4 servo wing, and it's even easier to install.
Good. Can we open the canopy to
It's
see
Josef
the technique
Mögen's
inside?
plane actually, so I'm very glad to open it because he's a master builder. But we need to be careful because he has his navigation in here. And there you see the motor, of course, and he's flying a 6S battery pack for the motor. And then he has the Swift from RC Electronics in here, which is the navigation headmaster, coupled to the GPS antenna. This is the GPS receiver, so to say. And this small bit in here, that's the RF module, which is sending down all the data which we are collecting in here to the ground station, so that we can navigate with the ground station. And this tiny little thing here, that's the variometer probe. So you have this coupling with the hose back to the TEK compensation probe.
Yeah, and have a look here. Josef has also painted the fuselage from inside, so he's really accurate with each detail, I can tell you.
Isn't that amazing? Yeah, you can see the pure passion of Josef.
Perfect. I think we have do everything, and somebody is calling you. Now the first visitor calls you.
Yeah, we need to sell.
Okay.
If you have any questions, now that you're calling,
phone him.
No, go to www.f3j.com. That's the Samba webpage, and you can get more or less any detail from the paradigm. And if you have any questions, send them an email. They are very nice people and they are really nice producers. So if you're interested in this plane, www.f3j.com.
Thank you very much, Phillip. And we hope that you can continue with this nice model. Let's have a look.
We'll keep our fingers crossed.
Okay. Thank you.